In this portion of the class, we're not only looking at the issue of sensors in robotics, we'll also be looking at an introduction to artificial intelligence. One field that crosses the boundaries between sensors and artificial intelligence is the field of machine vision. Machine vision is the question of how do we get usable information from an image or a video stream. Now, with other kinds of sensors, we're often trying to solve the problem of how do we use the little bit of information we can get from the sensor to give us usable information. But in machine vision, the problem is reversed. We get a huge amount of data from an image or a video stream, and we need to reduce that massive amount of data into just the little bit of useful information that we are looking to get. I'm going to show you an example of what I mean by telling you a little bit about how cameras work. Inside of a camera is a sensor. There's several different kinds of sensors that you can have in different kinds of cameras. One possibility is a sensor called a CCD, which stands for Charge Coupled Device, or you might have an APS, which stands for Active Pixel Sensor. These sensors consist of a grid of individual light sensors. An individual light sensor represented by these little blue squares that I've shown here on the screen. Each one of those individual light sensors detects light intensity, and it's an analog. Each one of these is an individual analog sensor, and we've arranged them into a big grid of individual sensors. Each of these individual light intensity sensors corresponds to one pixel when you would look at this image on your screen. The CCD, or the APS, this grid of sensors, might be a grid that consists of, for example, 360 columns and 240 rows, or more, such as 1920 columns or 1080 rows. The number of columns and number of rows tells you your image resolution. For example, 1920 by 1080 is HD resolution. So, supposing that we have an HD camera that we're using, we have 1920 columns and 1080 rows. That gives us 2,073,600 individual pixels or individual light sensors, which we would round up and say that that's 2.1 megapixels. That means that the CCD is recording intensity, light intensity, from 2.1 million individual light sensors. Each one is an analog sensor. Now, each one of these individual sensors detects intensity of light at a particular location in space. The complete area in space that your camera can see is called its field of view. So, for example, if your camera is focused on a 3 meters by 2 meters square of scene, then your field of view is 3 meters by 2 meters. So this isn't the physical dimensions of the light sensor of the CCD or APS. This is the physical dimensions in space that your camera can see. Each individual light intensity sensor detects intensity of light at a particular location in space. Then, the intensity of light, which is an analog signal, is converted to a digital value within some range. And I gave here as an example a range between 0 and 255. If you recall from the last video, the video on sensors in general, you might recognize that 0 to 255 is the range that you get if you are storing the digital value in 8 bits. The number of bits that we can store the light intensity into is called our bit depth. And the bit depth affects how precisely we can represent or recreate the gray levels in the images that we are taking. So each pixel giving us a value that is converted to an 8-bit byte or an 8-bit grayscale depth is just a grayscale image. We haven't yet looked at the effect of color, and we will in a moment. So what we found out is that a single HD grayscale image contains 2.1 million approximately pixels, and each pixel gives us a value that's stored in 8 bits. So that single HD grayscale image gives us 16.5 million bits of information. Now let's look at the effect of color. If the image is in color, then we have 3 sets of light sensors on a single CCD or APS. We have 1 set for blue, 1 set for red, and 1 set for green. How will this affect the number of bits of information that we get from each image? If the grayscale image gives us approximately 16.6 million bits of information, the color image gives us 3 times that much information, 49.7 million bits of information. When we are using a camera in robotics, many times we are trying to answer a simple question such as, is there an object in the camera field of view? We might be asking this question, for example, if we're using the camera to do a pick and place operation. And we want to know if the object that we want to pick up has arrived in the field of view or not. So our question that we're going to ask is, first of all, is there or is there not an object in the camera field of view? This question is a yes or no question. In other words, it's only 1 bit of information. The problem of machine vision in this case is that we need to reduce 49.8 million bits of information to just 1 bit. The methods that we learn in machine vision are all about how we manage to get rid of information that is not useful to us while preserving the information that is useful. In the next video, I'm going to start going through some of the mathematical approaches that we can use to get rid of non-useful information while preserving the useful information.